Well, hello, hello, hello. How do you do? I got work for you. Oh, yeah, that's what we're talking about. It's test 40. We're going to be focusing on equations. We want to be solving equations, but to get there, the starting point is this idea of function machines, you finding inputs and outputs because once we're comfortable with this idea of function machines, which we've probably met already, maybe a couple years ago, probably back in I don't know when you were in primary school, etc. But you might have met it. If we understand this idea of a function machine, then we can apply it to solving equations, and that's where I want to get to at the end of this session, at the end of this task 40. It'll be brilliant if you can write down the date. So just put in your date. And put in the task and the learning objective. To bat, just to remind you, is to be able to. That's what TBAT stands for, to be able to. I reckon you save, I don't know, over the course of a year, you're probably going to save an hour of your life just by writing TBAT instead of to be able to. Maybe, I don't know, just hey, gotta quantify everything. How gotta call it. Oh, it's all about numbers. It's all about numbers. Okay, right. So that's the bit you want to have your paper, and make sure you putting your papers together, so you have something useful for your vision in the future. And let's get to it. Okay. Starts off with an input. You have a function machine, so a set of operations to carry out. It could be more than one, and we'll explore multiple function machines. One step, two step, three steps. Yeah, three is coming. It's in there somewhere. And we find the output. So just to remind you of this, if I have four, and if do I need to remind you, I have four, and the operation, the function is multiplied by five. What's gonna be the output? Yeah, it's four. You need to do the operation times by five fours, then the output would be 20. Similarly, in a two-step function machine, well, we have to carry out the first operation. So 5, we need to multiply by 2. That will give you 10. And then the 10, we need to do the second function, take away 1. 10 take away 1, that will give you an output of 9. And that simple. That easy peasy. Ready. So let's not have me doing too much work. This is all about you. Here's four of them for you to do. Okay. Yeah. This is a one-step function machines. If you want to pause the video, you want to get these down, and you're right. What is the question mark? Question mark is what? What is the output on these? So off you go on those, please. Right, you should have paused, everything sorted out now. You got your pen out, green pen to do your marking. You're ready for this. You're adding, you start off with 4. 4 is your input. You add 6, that will give you 10. 3, remember, I hope, don't just write down the answers on your paper. Did you just write down just answers only? Stop the video, pause everything. Make sure you're writing the questions down. Write down, put down that whole function machine, then put in your answer. If you're not doing that, then okay, great, you got answers for now, but you don't have anything to look back at later on. What's the point in that? You need a tool. You need notes for revision, to look back at your whole mathematical journey to help you when it comes to the big day. They got big days, 3 days. Exams are 3 days normally, So, come on. Don't skip. No shortcuts. Next one, B. 3. You multiply by 10, you get 30. 10 is the input. The function take away 7. If I take away 7 from 10, I have 3. And then finally 14, I divide it by 2. The answer you should have to have 4 in a row all correct would be 7. Why? Because 7 twos are 14. Why? Because 3 plus 7 is 10. Why? Because 30 divided by 10 is 3. What have I been doing there? I've been going backwards. I'm setting you up for what comes next. What if I gave you the output and I asked you to find the input? What do you do? Do you remember that? Think about what I just said there. 7. What did I do to get to 14? But before we get there, I was jumping the gun. Oops, embarrassed face teacher. We're going to go in reverse, but before we got to do the two-step function machine. We didn't practice any two-step. Practice some two steps. So write down the function machines. Don't be naughty, skipping shortcuts. Pause me. Write down the function machine. I recommend even putting the intermediate steps, and then you put in your output. So I want to know what's the output to this machine. What's the number in the box? 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 Polly got a parrot. Polly parrot. All right, get going. Get going. Pause me. I smile. You know, sometimes the problem is the camera is not exactly a mirror, so I have no idea. I could be looking super silly, and I have no idea. I'm probably embarrassing myself, but you know what? So what? I am also enjoying myself because doing maths is fun. Are you having fun? You know what? Don't answer that. Okay, right. Let's do these. You paused. You had to go. You ran through the video. Let's run through. Add 4, I added 7, that will give me 11, and then I times by 5, and that will give me, I need to put it in a different color, 55. So the output is 55. 5, I take away 9. Whoa, we're going into the negative. Think about your number line. If you start at 5, you go down 5, you get at 0, but you were supposed to go down 9. Take away 9 is go back 9, go down 9. So I got to take away 4 more, which will get me to -4. Get me to -4. So -4 is my intermediate step, and then I multiply by 8. 8 4 is 32. And remember, if the signs are different, the answer is negative. 8 4 is 32, so -4 times 8 is going to be -32. And what am I saying 8 4 is? 4 8s to 32. That feels so wrong. 4 8s to 32. It's the same thing, but and I prefer saying 8 4s. 8 times -4 -32. Order does not matter in multiplication. Big idea there. Make a note of that. In other words, 2 times 3 is the same thing as 3 times 2. That might prove useful for one of the 1 markers you get in your GCSE exam. Order does not matter in multiplication. The posh thing we say is that it is commutative. Commutative law. You might not have heard of that term, but that's what it means. Commutative law of multiplication fulfills it. Order doesn't matter. Right, let's go on. Divide by 3. C. 6 divided by 3. If I divide by 3, I get 2. Then I have to add 9, and I should have been in my green pen. I get 11. Oh, yeah. And then D, -4. Times 3. One sign is negative, one sign is positive. The signs are different. 4 3s are 12, but because the signs are different, we have -12. Then I got to add 10, going up on the number line. -12. If I add 10, I'm not going to get to 0, am I? I needed 12 to get to 0, so I'm still 2 away from 0. If I add 10, I get to -2. The answer is -2. Am I right? How can I check? How can I check these? Because you should have been confident that you had these right before I did them. And the way to do that is to work backwards. That's how we do it. That's how we're going to find inputs. And let's just see. If I had -2, if I added 10 to -2, what would I get? Oh, are we getting in trouble here? Is that how you're going to do the checking? When you're going back, you're going to still add 10? No. If you're going back, and that's a big idea we're going to be going through next, what do you need to do? To find the input, what you need to do is think, okay, well, how did I get there? I added 10. So to go back, I need to take away 10. You're going in the other direction. And if you take away 10, you do get to -12. Yay! And then if you're going back, you're thinking, well, how did I get that -12? I multiplied 3. So to see what I started with, I need to do the opposite. I need to do the inverse. And what's the inverse of multiplying by 3? It is dividing. The opposite of multiplication is division. So I have my -12. I need to divide it by 3. If I divide -12 by 3, I will get -4. Yes, I will. So I can check by going backwards. And when you're going backwards, in other words, if you have the output and you want to find the input, you need to do inverse operations. Instead of, if I look at B, instead of multiplying by 8, you would divide by 8. Instead of, that's going backwards to check, and instead of taking away 9, you would Exactly, you would add 9. So check, check, check. Minus 32 divided by 8 will give me minus 4. And minus 4 plus 9 will give me 5. So I'm doing those checks. Are you doing those checks? Let's see if you're totally equipped to check now. We have those. We've sorted those. Boom. What is the input? Now we're working backwards. What's the input? Pause me, have a go. I've given you a frame here. And look at what we're doing in this frame. We're asking you, and I talked about it already. What's the opposite of my... Yeah, we'll do these together, and then you'll do the others. So what's the opposite of multiplying by 3? Yes, it's divide by 3. Divide by 3. What's the opposite of adding 2? It's taking away 2. So now I can go through 21. I want to divide by 3. If I divide 21 by 3, I get 7, because 7 threes are 21. And then I need to take away 2, and 7 take away 2, that will give me 5. And does it work? If it is, now you got to check. If I actually started off, if the input was 5, will I get 21? 5 and 2 will give me 7. 7 threes are 21. It works. The input was 5. 5 is the input to get 21 out of this function machine. Let's do the second one together. And then you have a frame. No, you're going to be building this frame in the others. I'll just show it to you. The others, yeah, no, I didn't want that. The other questions, I don't give you the frame, but you're going to have to build it, okay? So let's just make sure. We're doing the 2-step. Let's just make sure we got this right. The opposite of dividing by 3 is? Yeah, it's multiplying by 3. What's the opposite of taking away 10? Adding 10. So if I want to know what number I started with, I do the 4 times 3. 4 threes are 12. And then I have to add 10. What's 12 plus 10? 12 plus 10 is 22. 22. And let's see if it works. If 22 was the number I was starting with, I'll have to take away 10. 22 take away the 10. It's going to give me 12. Yes, it will. And then the 12 divided by 3 will give me 4. So 22 is the input. That's the number you would have started with in the second function machine to get a 4 as the output. Throughout, when you want to find an input, you're using the inverse operations. You might want to, if you know, I've talked about it. We've done about 5 or 6 now together. But this is a powerful, you're going to use this a lot when it comes to solving equations. Solving equation is working backwards to find out what the input is, what the starting number is. The function machine is a tool you can use to solve equations. That's what we've been doing so far, solving equations. You just didn't know it. You're thinking you're using it, you know, but it's finding the input of a function machine is solving an equation. Make a note of this. If it's addition, you're going to go back. You're going to use subtraction. From subtraction, addition. The opposite of multiplication, going backwards, the inverse is division. For division, if I want to go backwards and find out what I started with, I'll do the inverse operation. I'll do multiplication. Big ideas that you got to master. Let's use some of those. Here are 4 questions for you to do. What was the input? What was the input? Off you go on these. What was the input? Pause, have a go. Make your function machine go backwards. Thank you very much. I'll just run through answers for this now. The opposite of multiplying by 5 is dividing by 5. So 30 divided by 5, the number was 6. And you can check. 6 5s are 30. 12, the opposite of adding 8 is taking away 8. So the number I started with, 12 take away 8, which is 4. And we can check. 4 plus 8 is 12. Finishing off down here, the opposite of minusing 9 is adding 9. Let's check. 11 and 9 is 20. Let's check if it works. 20 take away 9, 11. 1 steps. And you're thinking, oh, yeah, easy. You see what I'm doing? I'm talking through the process over and over and over again. I'm programming my brain to think a particular way. And if you think in this way, then when it gets more difficult, and yes, it will, you know it will. I'm just warming you guys up. Of course it's going to get more difficult, but you'll be fine if you follow through these processes. Don't be skipping and thinking it's easy. Just work through the logic. Just keep working through the logic. What's the opposite of dividing by 4? It's timesing by 4. And 5 4s are 20. Let's check. Get in the habit of always checking. 20 divided by 4 would give you 5. So I'm sorted. We're sorted. We have all our numbers. Yeah, that's what we should have been looking at. Looking like, Here's a couple more for you to do. Here's a couple more for you to do. We'll spend a lot of time on these because these are so important for later on. What we're gonna do, what I want you to be able to do later on. Pause. Do these, please. Okay. Now, no, your function machine doesn't have to look like a proper function machine. I don't want you, just in case you've been, don't be wasting time making pretty rectangles. Come on, let's be serious about this, yeah. But you want to just get that structure with the arrows. Okay. So if you want to do these, please. Thank you very much. And make sure you write down the original as well. You wrote down the original. If not, pause again. Yeah. No, I'm not listening. I'm not listening. No buts about it. Pause, get the original down, then do the inverse. Right, going backwards. Thank you very much for listening. I appreciate it. Merci beaucoup. Merci beaucoup. All right. The opposite of multiplying by 4 is dividing by 4. The opposite of adding 1 is taking away 1. So 12 divided by 4, which will give you what's 12 divided by 4? 3, and then 3 take away 1 will give you 2. 2 is what I start with. 2 and 1 is 3. 4 3s are 12. I check. Going backwards, the opposite of multiplying divided by 6 is multiplying by 6. I'm just going to do these super fast now because I want to give you the answers. We've gone through enough of this, I think, for you to practice. So it should have been multiply by 6 and then take away 7. And then you have 4 6s are 24. 24 take away 7. That will give you 17. And we check 17, 3, 4, 24, 24. Right. So 17 should have been your answer. Then 37 take away 9. Divide by 4. 37 take away 9. If I took away 10, it would be 27. So what I'm looking at is 28. 28 divided by 4 is 7. Going forward, 7 4s are 28. 28 and 10 is 38. So 28 and 9 is 37. I've got that right. Then the last one, take away 20. Instead of taking away 20, we're going to add 20. That will get me to 54. 54 times 9. Instead of timesing by 9, I'm going backwards, so I have to divide by 9. That will give me 6 as the answer. 9 6s are 54. 54 take away 20 is 34. I'm happy. What would be really, really embarrassing is after doing that, if I have to get a comment on YouTube saying I made a mistake. And hey, I am human. That was slick. I felt good doing that. I was trying to show off. Yeah, a little bit. Is that cool? Yeah. Right. Now, if you got 3 right, if you got at least 3 right, 3 out of 4 or more, 3 or more right, then don't worry about doing B. You're going to move on to the next bit. If you did not get at least 3 right, then I want you to do these. Okay, so these are only for people who've done, if you didn't get 3 right, you're doing these. Pause and do these. Otherwise, hey, just watch me do it super fast now, and then we'll move on. See if you can do it as fast as me. So everybody will just try to do it as fast as me. No need to write it down if you got 4 out of 4. Take away, add 1. You should have paused and had to go if you got it wrong. If you didn't get 3 right last time, you're doing these. You should have paused and done them already. Yeah. Thank you very much. Now, add 1. That will give me 8. Whoa, what's happening here? Add 1 will give me 8. Oh, this is hard. I should have made everybody do this. Divide by 6. Well, no. What am I doing? I'm muddling myself. Multiply by 6. 48. 48 divided by 6 is 8. 8 take away 1 is 7. Okay, great. 9 multiplied by 7 is 63. 63 plus 6 is 70. 70 take away. Oh, no. 63 plus 6 is 69. 69 plus 6 is, take away 6 is 63. 63 divided by, okay, right, that seems fine. Divide by 4 will give me 6. 6 take away 8 will give me minus 2. Minus 2 and 8 is 6. 6 4s are 24. That looks all right there. And then minus 3 plus 7. Minus 3 plus 7. Take away 7 is what I'm doing because I'm going backwards. Take away 7. Minus 3 take away 7 will give me minus 10. And minus 10 divided by 2 will give me minus 5. Minus 5 times 2 is minus 10. Minus 10. Okay, right. So those are the answers you should have had. 48, 69, minus 2, minus 5. I don't like that. Okay, yeah, we're fine there. Right. 63, 63. Okay, yeah. All right, so those are your answers there. Okay, right now I'm trying to do that as quickly as possible so that those of you all who are confident on it, we didn't lose too much time on that. Now, a triple. Yeah, I told you I was going to do a triple. Never did one of those before. So even if you thought you were expert on function machines and thinking, oh, I can do this already. Yeah, let me see you now. Okay, off you go. Pause. Same idea applies, but now it's 3 operations that you need to follow. Have a go at this. I'll do it after. Have a go. Right. The output is, you know what? You have a go. I'm just going to run this live because for this one, I'm just going to give you the, actually, no, I'll do the whole thing. Fine. Right, 7 eighths, 56. 56 take away 5 is, I should have put the 56 here. So for A, 56. 56 take away 5 is 51. What am I doing? Yeah, I do have 7 8. 8 sevens are 50, 7 eighths are 56. 56 take away 5 is 51. Really? That's what they wanted me to do? 51. Okay, fair enough. 25.5. 25.5 is what we're getting. Good thing that I'm actually doing this. Ooh, that's ugly. Did he feel uncomfortable doing that? I hate. There's something about not getting a whole number answer, isn't there? But that's what it is. You know what? We'll do it. What's the output if the input is 8? Input is 8. 8 sevens are 56. 56 take away 5 is 51. And half of 51 is 25.5 or 25 and a half. So it has to be right. What is the input if the output is 22? We're going backwards. 22. We have to multiply by 2, which will give us 44. 44 we have to add 5, which will give us 49. And then 49 divided by 7 would give us 7. So the answer for B is going to be 7. The answer for A was 25.5. B is 7. And then finally C, what is the input if the output is minus 13? So now what we need to do, whoa, I'll work that one out in, what color have I not used? Blue. Right, so we start at minus, what is the input if the output is minus 13? Sorry, I'm being a bit lazy on this one, shouldn't I? I should give you guys, oh, let me give you all a clean page so we can work on it clearly. Put the answers back. Right, okay. Right, so what did we have? We had, see, I'm there with you guys. I don't ask you all to do things that I'm not doing for myself. 25.5 and then 7 was the answer for B. And then for C, minus the what is the input if the output is minus 13? Minus 13 divided by 2. Oh, seriously, sir? Yeah, minus 6.5 is what you want. Then you need, so, whoa. What did I do wrong there? Oh my goodness, yeah. And that is a big mistake that a lot of people make with questions like this. They forget that going backwards, you need to do the inverse operation. So what do you need to have? You need to multiply by 2, you need to add 5, and you need to divide by 7. Those are the 3 operations if you're going backwards. So it was negative 13 times 2, which will be negative 26. Negative 26 plus 5. You're going up on the number line, which will give you negative 21. And then negative 21 divided by 7, that will give you negative 3. So the answer, the third answer is negative 3. Negative 3 times 7 is negative 21. Negative 21 take away 5 is negative 26. You're going down on the number line, negative 21. Going down will give you to negative 26. Going up, that's down 5. Up 5 will give you 20. What am I doing? Oh man, that looks terrible. That looks terrible. Let me fix that. Right, we're doing good for time. Yeah, we're doing good for time. Right, what are we looking at there? Negative. I just want to show you because I know some of y'all don't like this negative numbers thing. So if I started at negative 26, if I add 5, if I take away 5, let's just show what's happening there. And we actually want it for negative 21, don't we? So negative 21. If you have negative 21, if you add 5, you're going up. You will get to actually no, I wanted it for, is it 26? We'll do for 26. If I add 5, I'm going up, so I'll get to negative 21. If I take away 5, I'm going down, and this, if it was taking away 5, I'll get negative 31. That's just showing you why we wanted the negative 21. And then the negative 21, if I start at negative 21, note I'm taking away 5, going up, so I'm getting to negative 26. This is going forward, taking away 5, negative 26, and dividing that by 2, negative 13. Yeah, so yeah, we are fine. I have made my checks, and I'm just showing you that up and down with minus 5 using 26. We didn't go down for minus 26, we went up 5, so we ended up with minus 21 If we went down 5, it would be minus 31, okay? Right, okay. This was 9. Okay, right. This is the next question I would like you to do. Word problem. The idea here is you reframe this question as a function machine. Try to do that. Reframe this as a function machine, and then you'll be able to get the answer. Pause, have a go. And let's see what this should look like. Number is multiplied by 10. So I have an input. I'm going to upgrade things now, and I'm just going to say the number is x. And you'll see where I'm going. Now we're getting into that point where we're going to use the function machine strategy to start solving equations. I'm making that shift now. So instead of the input, that's the idea I want you thinking about. Your input is what we refer to as x when you see all these equations. We'll come into it in a moment. Okay, so the input is x. Some number. I don't know what it is. I'm calling it x. I want to find out the value of that input. I want to find out the value of that x. So what's the first thing I'm doing? Multiplying by 10. Multiplying by 10. Remember, you should have paused and had a go. Yeah, power of the pause. If you didn't have a go, based on what you're seeing from me now, you got, oh, that's what you mean. That's how I do it. Then stop me now and you finish the job for yourself. That's the power of the pause. And then compare what you're doing with what I'm doing. That's how you get the most out of this. Not just by watching the whole thing. It's about as soon as you have enough, stop, do it. But you should have tried for yourself, okay? So multiply by 10. And then it says that 6 is added. So that's another function. I need to add 6. And then the output to get. So after I perform these functions, after I multiply by 10 and add 6, I get 36. So that 36 that's the output. So I know the output is 36 of my function. To find out my input, to find out the number I started with, in this case is x, you got to go back. So now we're using that inverse function machine. So it's take away 6. I'm going back, so I got to take away 6. I'm going back, so I have to divide by 10. That's what I'm going to do. That's my two-step function machine. So 36. The first thing I was doing was I'm starting with 36. I got to take away 6. That gives me 30. Then divide by 10. That gives me 3. Boom. Boom, boom. That's what we're talking about. We're saying x is 3. The input is 3. Look at that. If we check, 3 times 10 is 30. 30 plus 6 is 36. Oh boy. Now let me go a little bit further, because this is what we're going to be doing next. I just want to show you how you can use the function. That's a big thing here, not the function machine of itself, but how you can use it as a tool to solve equations. That's a technique I want to develop if you weren't, and embed in you as a strategy. So how I could have written this using algebra. When I was thinking about x and it's multiplying by 10. When I multiply a letter and a number, well, we don't use the multiplication sign in algebra. We can just write the number and letter together. So this whole question can be written as an equation to solve. This can be solve x, the number we're trying to find is being multiplied by 10. So 10x, that's what 10x multiplied by 10 is in algebra. 10x, we put the letter and the number together. Number goes first. And then we have to add 6. So plus 6, and that is equal to 36. To get means equal to. So add 6 to get 36 equals to 36. If I take my number, I multiply it by 10. That's what 10x means. And then I add 6. I will get 36. If I gave you this question, solve 10x plus 6 equals 36, you could have modeled it by using this function machine and then going backwards using the inverse function machine to get the answer 3. You can use function machines to solve equations like this. And that's a big moment. That's a big idea I want you to take away from this exercise, really. Let's look at another one. And whoa, bigger one there. And remember, if I move too fast there, remember, you can go back. Power of video, just go back, repeat. You got that power there. You control me. Even if you think I'm talking too fast, you can slow down the video. Yeah, you can do that as well. Fine. Okay, pause and try and model this question as a function machine. There's three things happening. I've restructured the question to make it a bit clearer. So it's a three-step function machine. Try and build that three-step function machine and use it to solve this problem. Off you go. Make that happen. Make that happen. And yeah, you can make it a two-step function machine. You can reduce the three steps to two if you want. Think about it and see what you come up with there. Okay, right. Right, so you've had your moment. Now it's for me to build on this. So in the first week, we want the height of the plant. Yeah, we want the height of the plant, getting the key information. Height of the plant, when he bought it. So the input, we want the input, the height of the plant when he bought it. It is now 35. So the idea you're thinking about here is that the input is the original height that we want to find. The output, and we're gonna call that x, because I want to go from function machine to just show you what it looks like. This whole thing could have been written as an equation. Okay, so input is x, and the first week it doubles. Doubles is what operation? Multiply by 2. So I have to multiply by 2, and then in the second week it grows by 8. If something grows by 8, it's at the height, and it goes up by 8. Going up is adding. So I'm going to add the next function. The next step is add 8. That's what you should have. And then in the third week, it grows 5. So your next step is going to be add 5. And that's what I'm saying, that you can actually make this a two-step machine because, well, if you're adding 5 and then you're adding 8, well, hang on, all you're doing is adding 13. So it could be times 2 add 13. That's a simpler version of the function machine. And then all of that gives an output of 35. At the end of this process, I have a height of 35. So that's what you should be looking like. How do you feel about that? Yeah? And once we have that, well, we want to find the original height. We're going backwards. You have your chance. If you didn't do it, you still have your chance to take charge of this moment and to have success. You can pause the video and get the answer for yourself if you haven't already. Or if you do have the answer, you should start thinking, oh, yes, I did that. I'm so close. You're almost there. You're almost there. Do you have success? We're going to find out. We're going to find out right now. Let's look at this. I got to scroll up a little bit, and we're going to go backwards. I'm going to go in green. We're going backwards from 35. And I didn't write what was the operation. Don't write just numbers. It has to be add 13. And the opposite of adding 13 is I got to take away 13. And then I need to divide by 2. So 35, take away 13. I'm going backwards. Take away 13. That will give me 22. 22 is what I'm going to get there. I'm going to write that in red. And then I have to divide by 2. And that gives me, do you have it? Do the dance. Oh yeah. 11. Way. 11 is the answer. Have I done it right? We got to check. Did you check? Come on. In the exam, when you do questions like this, you don't just get an answer and move on. No. You got to use the power up to check. Make sure you did it right. Go forward. Do the opposite. Let's check. 11 twos are 22. 22 plus 5 is 30. 30 plus 5 is 35. Oh, yes. That's what we're talking about. That feel-good factor. Wow. Beautiful. I feel good. Okay, let's move on. Let's see what we got here. As I was saying, and what I showed you there, actually, and let me go back. This one here, we could have written it as an algebraic equation. I just want to show you that, and then I want you to try to do the others. Writing in an algebra, if I look at this function machine, I'm thinking, okay, right, I had some value x. It was multiplied by 2, so that's 2x. And then I added 13, and as a result of doing that, I got 35. That's the equation you were solving. You just solved 2x plus 13 equals to, well, would help if I wrote 35. I said 35, but I wrote down 25. You just solved 2x plus 13 is equal to 35. Now what I want you to do, and we're going to finish, we're on the final lap now. We're coming to the end. I want you to, all these equations, I don't want you to just solve the answer. These are one step, so I know you're going to just think, some number. I've been in this game no long time to know that for the first two questions, people are going to do all sorts of interesting things in their head. But what they're going to do in their head will not be giving you a method that will help when the questions get more complex. So function machine. Build a function machine to represent all of these. What does it look like? And I want you to pause and have a go. But I'm actually going to do them quickly because I got another rep for of these as well. So if you prefer to look at me doing these, that's fine. But if you want to do them, solve them, but using a function machine and going inverse. So what am I saying? I had some number x. Remember, x is your input. That's the logic you want to think about. X is your input. I'm adding 3. So I take x, I add 3, and the output is 9. So if I want to know what the number is, what's the value of the number, I go back. So that means I need to take away 3. So 9 take away 3, and that will give me 6. So for A, the answer is 6, and you can check. 6 plus 3 gives you 9. Then similarly for B, same thing. What's the function machine setup of this? I start off with x, and I am taking away 5, and that is giving me 6. I need to make this a bit clearer. I take away 5, and that is giving me 6. So going backwards, what's the opposite of taking away 5? It is adding 5. So 6 plus 5, that gives me 11, and I can check it here. 11 take away 5 is 6. It works. The function machine is a powerful tool to solve equations. That's what I was trying to show you before. If you weren't seeing it before, maybe in this direct approach, we don't have the word problems anymore. But then think about it. All of a sudden, complicated word problems, but you get what I'm saying. You know, those tricky things which you might have thought, you can. Yes, you can do it. That's what we're talking about. Here, what does 4x mean? It means your input x, it has to be multiplied by 4. So my operation for C, I'll put C here, x, it has to be multiplied by 4, and as a result of multiplying by 4, I'm getting 28. So what was the number? I got to go backwards. The opposite of multiplying by 4 is dividing by 4. 28 divided by 4 gives me 7. So it was 7. X is equal to 7. 4 times 7 is what will give me 28. So x, the value, the missing number is 7. And last one, the division. You might have seen one of these. You know what's your answer? A popular answer for this question, loads of people, I see it time and time again. Examiners love this because you see 5 and you see 10. Whoa, 10 divide, and you have divide, 10 divided by 2. You think 10 divided by 5. A lot of people are going to put 2 for the answer. Did he put 2? A lot of people. This one, D, so many people. They always put 2 for the answer. That is wrong. Let me scroll down and deal with this. This is such an important one, D. Let me make it go down a bit further so you see it. 2 is the most popular answer I will see for young people here. In terms of people who got it wrong, they'll have 2 as the answer, and that is wrong. 2 divided by 5 won't give you 10. But the way you need to think about it to model it is I start with x, and what are you doing? The first thing, the fraction bar means to divide. So you're dividing it by 5, and as a result of dividing it by 5, that is how you're getting 10. So to find x, to find the number you started with, you need to go backwards. The opposite of dividing by 5 is, gotta change my pen color, is multiplying by 5. If you do 10 times 5, you get 50. So the number is 50. 50 divided by 5 will give you 10. That's the logic. This is what I expect to see as you're working at this stage. And even if you have a method you're comfortable with, the most powerful thing you can give yourself developing is embracing, practicing other methods and getting to the stage where you have multiple methods to solve the same problem. And on the day, you decide what's the best method to use. But you don't want to just have one method to do something. You want to have lots of different tools, lots of different strategies that you can pull from. Do these 4. Do these 4 function machine method. Get in that function machine as I was demonstrated. If you've forgotten already, go back and watch what I just did. And you're doing it just like that. I want these 4. Yeah, okay, right. So you pause and you do that. Good. You did it. You were in the routine. I'm going to put the answers now. You should have had 6. 6 and 4 is 10. You should have had 14 because 6 plus 8, that's what you're going backwards. So you're adding 8. The opposite of minusing 8 is adding 8. Here, this is multiplication. This is x multiplied by 5. Let me stay consistent with my colors. What you have is x being multiplied by 5 to give you 25. Going backwards, the opposite of multiplying by 5 is dividing by 5. So 25 divided by 5, which will give you 5. 5 times 5 is 25. So x is 5. And then the last one here, no, you're not going to put what's the temptation to put 2 as the answer. Again, 6 divided by 3. It's just so tempting. You know, this 3 is down there, the 6 is up there. No. X is being divided by 3 to get 6. The opposite of divided by 3 is multiplying by 3. The answer for D is 18. You should have 18 as your answer. Using your function machine, you should have realized that you needed to do 6 times 3. Now, to finish off for today, we want to use this same strategy. You should be in that zone using the function machine. We want to be doing that. We want to be doing that with two-step equations. Use your function machine method to solve these two-step equations. I'm just going to do the first one. For the first one, what's happening to x? It's being multiplied by 2. Start with x. What's happening? It's being multiplied by 2. After it's multiplied by 2, what's happening? You're adding 3, and that gives you 17. Now you got to go backwards to find out what x was. So you're going to take away 3, you're going to divide by 2. 17 take away 3, 14. 14 divided by 2, 7. So the answer, x is 7. 2 times 7 is 14, plus 3 is 17. Do the other two. Follow the same strategy. Pause, do them. Build your function machine. Use the inverse function, get your solutions. Remember, fraction bar means to divide. Off you go, make it happen. Let me look at it now. What should you have had? Going backwards, you had 8, and then you wanted to add 4. So I'm just building the backwards. You're adding 4 to get 12. Then you're dividing by 3. The opposite of multiplying by 3 is dividing by 3 to get 4. So the answer should be 4. 4 3s are 12. 12 take away 4 would give you 8. Here for C, I'm going to build this function machine because it's so important. X, you were dividing by 4 going forward, and then the second step was to add 6, and that was giving you 14. So going backwards, you're going to take away 6, and 14 take away 6 is 8, and then 8 divided by 4 is 2. It is tempting, you know. 14, you can easily add 6, get 20, and then 20 divided by 4, you will get an answer 5. And that's why these things are, you just got to make sure, have you followed systematically the structure, the strategy, okay? And then you check. You have to check and see if your answer is working. And when you check, look at what's happening here. 2 divided by 4. Oh, it's a fail. Why? What have I done wrong? Did you make a mistake like that? You can see how easy it is to make mistakes in this thing. What happened there? I did not write. I failed to write down. I skipped a step. I tried to do it in my head. I failed to write down the inverse operation. Instead of divide by 4, when I'm going backwards, I need to be multiplying by 4. So that 8, when I had that 8 there, it needed to be multiplied by 4. 8 multiplied by 4 is going to be 32. 32 is the answer. But I only picked up that. The only reason I know that is because I did a check. If you don't do the check, you're going to burn marks in the exam. What does it take out of you to check? Look at what happens. I made a check, and now I'm going to check again. 32 divided by 4, that gives me 8. 8 and 6, 14. Yes, it is right. Don't skip your check. Let's finish off. We're on the end. Do 3, and we're done. Do these 3, and we're done. So here are your answers. X is equal to 11. Make your check. 11 2s are 22, and 5 27. For B, x is equal to 6. 6 5s are 30. Take away 2 is 28. And for C, 45. 45 divided by 3 is 15. 15 take away 10 is 5. And there you go. The power of the function machine to solve equations.